So let's read the definition of expected value. It says, suppose the possible outcomes of an experiment or a random process are real numbers a1, a2, and so on, which occur with probability p1, p2, p3, and so on. So a1 occurs with probability p1, a2 with probability p2, and so on. The expected value is the amount that you get when you multiply the a with the p and then sum up over all of the real numbers, basically, that you have in the problem. So for us, the A1, A2, A3, and so on are going to be the gain in this example. So suppose that 500,000 people pay $5 each to play a lottery ticket or to play a lottery game in which the following are the prices. So you win, the grand prize is $1 million and there's only one single one of those. So like, for example, if you are the winner of that money, how much gain did you end up with? Well, you spent $5 to buy the ticket and you won $1 million. So basically you ended up gaining $999,995 because you spent $5 to earn that money. So in my case, that would be basically the A1. So I'm going to call that the gain. Okay. Now, if you were the winner of $1,000, for example, then what was your gain? Well, you paid $5 to win the $1,000, so you basically won $995. I'm going to call that A2, and there's 10 of them, so it's going to be also A3 all the way up to basically A11, for example. Does that make sense? And so on and so forth for the rest of them. So when I take all those A1, A2, A3s and whatever and multiply them by the probability, then add everything that I have in the problem, I get what's called the expected value, which is what I'm trying to calculate in this problem. So let's talk about the net gain, and let's make a table here to help us understand what's going on. Okay, so I'm gonna make a table. In this table, I'm gonna put the money spent on one ticket. So each ticket costs $5, so this is gonna be always a $5. So $5. And let's say I won the grand prize, which is $1 million, so 1 with a bunch of zeros. Then how much money did I gain? Well, I spent $5, so that's considered like a loss, -5. And I won the $1 million prize. So in total, I ended up winning, so I got money basically, and I ended up winning $999,995. That's how much money I won when I win the grand prize. And by the way, there's only one of these, so only one ticket will win this amount. Okay, so now let's talk about the next best thing that could happen, which are the $1,000 prices. So you have lost $5 because that's how much you spent for each ticket, and you won basically the $1,000, so that's a plus, that's an added amount. But what did you actually gain? Your gains were, again, a positive amount, but you only gained $999 and $5. So $9,995. Sorry, this is wrong. It's $995. And how many of those were there? There were 10 prices, so there are 10 of these tickets. So far 11 tickets have been used out of the 500,000. Let's keep going. The third price wins $500. So again, you're gonna spend $5 to win one of those prices. You're gonna win pretty much $500. So your gain is gonna be $495 at the end of the day. And how many of those tickets are there? There are 1,000 of these tickets. So far it's 1,011 tickets that have been gone out of 500,000. Okay, and finally the fourth prize, they win $10 each. So they're gonna spend each of them $5, and they will win the $10 amount. So their gain is still positive, but they're still gaining very small amount, $5. And there are 10,000 of these tickets. Cool. So that's the 1,000, 10,000, 10, and a grand prize that means 1. Okay, so far so good. All right, is that the only thing that's gonna happen? Well, no. There's gonna be a lot of losers. Okay. So keep in mind that there's a lot of people that win the lottery and that play the lottery and not win anything. So there's a lot of people that are gonna spend $5 buying tickets. They will win $0. So at the end of the day, they would have lost, not won, $5. So that's how many of them? Well, it's pretty much 500,000, which is how many tickets there were at the start of the problem, minus all of these numbers in blue. So there's 10,000 and the 1,000 and the 10 and the 1. Okay, so let's put that in a calculator and find out what the amount is. So that's 488,989 tickets. Okay, so the numbers in blue represent the tickets. Okay, so these are the winning tickets or the losing tickets, basically. Okay, so be careful. All of these up here are winners, and all these guys are losers. So there is 10,000 roughly speaking winners, but there's 480,000 roughly speaking losers. So these people have won, winners, and these people have lost. Okay, so these people have won and these people have lost. Okay, perfect. So now I'm gonna determine the probability. What's the probability of winning or losing? So the probability of winning or losing is pretty much the same for everybody. The probability of winning or losing is the probability of 1 divided by 500,000 tickets, because that's how many tickets there are. Okay, so that's the probability of winning or losing. So there we go. At this point in time, I just have to basically tally it all up. So my expected value in this problem is gonna be equal to the sigma I or k or whatever from 1 to 500,000, because that's how many tickets and probabilities there are. So I'm gonna have to multiply the number of tickets or the gains of each ticket by the probability of that ticket. So basically I'm gonna multiply these two numbers once, these two numbers 10 times, these two numbers 10,000 times, so on and so forth. So basically it's the AK times the PK, but the PK is always the same. It's 1 over 500,000. So it doesn't matter how many tickets you bought, that's how much your probability is. And since that probability is the same, we're gonna factor it out to make life easier. So it's gonna be, let me save space and put it right here. So it's gonna be 1 over 500,000, since it's the same for all of them, and sigma k going from 1 to 500,000 of the AKs. Remember, the AKs are pretty much these numbers right here, multiplied by how many of the tickets there are. Okay, so let's go ahead and put it all together. So there's one ticket that wins the grand prize, 999,995. There are 10 tickets that win the next best thing, so 995. There are 1,000 that win the third prize, 495. There are 10,000 that win the $5, and there are a lot of losers. There are 488,000, so that's why I'm putting a minus. They lost the $5. Okay, so is that making sense? All right, so now we're gonna punch everything into the calculator and we'll find out that the answer will be negative 1.78. And by the way, this is a dollar amount, so this is a dollar amount. So in other terms, on average, people will lose $1.78, so $1.78 if they keep playing this lottery that is described in this problem. So before I move on, I want to clarify why we put the 1, why we put the 10, why we put the 1,000, and so on over here. Okay, why did we have to put those, even though the AKs were basically these guys? The AKs are the 5, the 5, the 95, the 95, and whatever. Okay, so the 10, the 1,000, and so on, this is how many tickets there were. So it's not just one ticket that wins the $995, for example. There's 10 of them, and I'm supposed to add each one of those multiplied by its own probability. And I don't want to write down 995 10 times and then 495 1,000 times and so on. So that's the reason why there's the 10, the 1,000, the 10,000. It's basically to get me to go from 1 to 500,000, basically. So I have to calculate 1 of the grand prizes, 10 of the next second prize, 1,000 of the third price, and so on. But it's not convenient to write all of them down. This is the reason why we're putting the 1, 10, 1,000, and so on. I hope that was clear.